Today we will be going over a demonstration of LINSTOR, that is Linbit's SDS solution that includes DRBD and other native Linux storage tools. Today's speakers, we've got Philip Reisner, who's the CEO and founder of Linbit, and he is also one of the core developers of DRBD. And we also have Renee, who is responsible for development of LINSTOR and the lead on the CloudStack integration of LINSTOR. So I guess with that, we'll go ahead and get started.
Thanks for the introduction, Brian. Then I will speak a few minutes about LINSTOR and then hand over to Renee for the interesting demonstration. Yeah, so the motto of LINSTOR is the combination is more than the sum of its parts. So LINSTOR is about orchestrating and automating all these storage building blocks we have on the Linux platform. And just in the last session, I spoke about DRBD, but there are a lot of other, let's say, gems in the Linux storage software space. Like we have LVM for slicing up the storage. It can do thin provisioning. It can do efficient snapshots. We have video for deduplication. We have dencrypt and looks for encrypted volumes. There is CFS or ZFS, which brings a bunch of features and so on. So and caching, so many implementations of caching. And all these building blocks, they are compatible on the data plane. What I mean with that is we can combine all these building blocks, but many of them bring their own management tools. And this is exactly where we hit with LINSTOR. So the idea is LINSTOR can combine all these things for you and manage them for you. And LINSTOR gives you a REST API to build these storage stacks. And on top of that REST API, we have then the connectors to the workload orchestrators like Apache CloudStack. So let's look at how that works. So let's say we have a cluster of 6 machines, and these machines are ready to be used as hyper-converged hypervisors. So they have enough CPU and memory to run the actual workload, the virtual machines. But they also have built-in storage devices. And between the hypervisors, we have a capable network. Let's say it's a 10 gigabit, maybe 25 gigabit, or even a 100 gigabit network. Now, if LINSTOR gets in the request for a new volume, it already knows where the orchestrator, where CloudStack plans to run the VM. So what it does is it tries to place one replica where the VM will run and places the other replica on some other host. The fact that it places 2 replicas, that is in a resource group in LINSTOR, and you can have multiple resource groups with different characteristics, and that could be exposed as different, I'm lacking the term, storage pools, whatever they're called in CloudStack. Sorry for that. Now, in this example, we want 2 replicas. So right now, the whole thing is, let's say, in the optimal layout, because we have the orange VM with 1 local replica and the black VM with 1 local replica. And for the purpose of surviving node failure, we have a second replica of those somewhere else. So read requests will be fulfilled locally. And we also save bandwidth on our network, right? Because we only send writes over the network. Now, what can happen to a system like that? There might be a live migration. So let's assume the black VM is migrated away. And that works. And the LINSTOR software will reconfigure DRBD on the fly to have a diskless node in the DRBD config here. And it exposes the same block device to the KVM process running the virtual machine so that KVM can do the live migration and has the storage available on the target node. So that's completely transparent to the VMs. But the difference is now we don't have a local backing volume here. So what now LINSTOR can do on the fly is, and that only works if enough free storage is available in this volume group, LINSTOR will try to allocate here a new replica. If that works out, it will instruct DRBD to resync all the data over. And when that is done, it removes the third replica because this storage class only wants 2 replicas. So it can migrate the storage behind the scenes on the fly, transparent to the VM, to the node where it should be. And this can make a lot of sense, but you don't need to do it. You can also configure LINSTOR to not do that at all and to continue to run with a cluster that looks like that. So that was LINSTOR by example to give you a feeling what it does for you. Now let's look at the parts of LINSTOR. So LINSTOR has 2 main parts. One is the LINSTOR satellite. The LINSTOR satellite runs on every node in the cluster. So in my previous example, we would have 6 instances, 6 of each on each node, a LINSTOR satellite. The LINSTOR satellite is stateless and configurationless. So all you need to do is you install the daemon and make sure the daemon gets started when the system boots. Then the satellite is contacted by the controller. So we have only one instance of the controller per cluster, and the controller is stateful. So it knows the cluster, it knows all the nodes, so it reaches out to the nodes, it establishes connections to them. The controller does the, let's say, the central orchestration of the whole system. It sends the work requests to the satellites do the local actions like creating logic volumes, taking snapshots, or configuring DRBD devices, or creating the metadata for a DRBD device. The LINSTOR controller itself can be made highly available. For example, you can put its own database on a DRBD device. And then there is a very lightweight component to manage the failover that's called DRBD Reactor. And on top of that, we have the REST API LINSTOR controller exposes. And there is a CLI. So you have a command line interface to interact with LINSTOR. There's also a small client-side library, and then the Apache CloudStack driver uses the library or the REST interface. I need to give the word to Renee to answer that. So that's the components. And one thing that's really important to remember when you see this picture, this is only the control structure of LINSTOR. So LINSTOR uses that to establish new volumes, but the volumes are then independent of the control structure. So that means a volume that is passed to a virtual machine and offers I/O to the VM is independent of the satellites of the controller. You could restart them. You could relocate the LINSTOR controller. You can upgrade the LINSTOR controller. I/O for that VM will continue to run. So we have a clear separation, a strong separation between the control path and the data path. Now, let's look at the objects LINSTOR deals with. So the LINSTOR controller needs to know all the nodes of the cluster. It knows the volumes, and volumes are embedded in resources. It knows snapshots, storage pools, and what might be a storage pool. It might be a LVM volume group, a CFS pool, a shared LVM volume group, and we also have a few hardware appliances, one from Western Digital and one from Seagate that is supported by LINSTOR. And then the resource group, that's like let's say the central element. So in a resource group, you tell LINSTOR how many replicas should those volumes have, where should they be placed, should they be encrypted. Actually, you define the whole I/O stack you want to have for these volumes. And then there's a one-to-one mapping from the resource group to a CloudStack storage pool, I guess is the name. And yeah, then there are properties and nodes, and that are used to fine-tune how LINSTOR allocates things. So here a slide to illustrate the storage stack that LINSTOR can build for you. So what we always have is something that can store data. So that will be the LVM thin, or a CFS, or a few other things. And then we could have optional parts, encryption, caching, maybe a NVMe target and initiator in between. And then on top, we have DRBD, but also that is optional. So you can also have resource groups that give you ephemeral volumes that are not guaranteed to survive node failures or storage device failures. And yeah, that there might also be software RAID and VDO deduplication in the stack. Yes, then I have here a few details about LINSTOR's data placement. So in the resource group, you could have a policy that is really complex. So that says something like all volumes should be three-way redundant, 2 copies in the same rack, but a different, and a third copy in a different file compartment, or similar things. And these policies can refer to completely arbitrary tags. And with tags, you attach them to your machines, and you could have a tag rack, and that has then different, as a content that has then different numbers on the machines. And you could also have a room tag or maybe a chassis, and then refer to these. And then similar, it can support you with selecting the right path over the network. So one example we had here is we had a customer that was building storage nodes with 2 sockets, and the machines were fully equipped with NVMe drives, and then 2 NICs. And it turns out that on an Intel system, when you export the volume from such a storage server, that the data stream should not cross between the 2 sockets, because the link between the 2 sockets can become a bottleneck. So here the important decision was, always select the right NIC when you export this storage to the network. So things like that. Okay, I hope that I gave you a theoretical understanding what LINSTOR is at this point. And now I want to give the word to René, who will do a demonstration in the context of Apache CloudStack.
Well, not in the context of Apache CloudStack yet, because that's in the next session, but
oh, sorry. Then just a LINSTOR demonstration.
Yeah, for now, the LINSTOR demonstration. So I have to share the screen. So I hope everyone can see it. So what we have is here on my workstation, and I have 3 virtual machines which will host the satellite, and the controller will run on the host itself. I already started with creating 2 nodes or satellites in the LINSTOR cluster. So we have here LINSTOR node 1 and 2. These are also of type satellite. There are IP addresses and they are online. So what we'll now do is we'll just add third nodes. So you see how complicated this is. So if the name can be resolved to an IP address, you just have to enter LINSTOR node, create LINSTOR, and then the host name. And the rest will be resolved from the IP address. And yeah, you get some information about that node, like what storage provider it currently supports, and what resource layers, and what kind of errors the other detection got. For example, my satellites don't currently support SDK because I simply didn't install the SBDK software, and the same is for the Exos support. And I don't have the NVMe on the virtual machines enabled, nor and also the same NVMe stuff is needed for OpenFlex, but usually I don't need that, so I don't have it here. But we have still enough storage providers and resource layers to do something fancy. So after you have nodes in LINSTOR, you usually need something where you can store stuff. So you need storage pools in the context of LINSTOR. So you see, we already have some kind of storage pool here. It's called, it's a diskless storage pool, and this is default created by LINSTOR for every node. So this default diskless storage pool will act for diskless resources in DRBD. So you don't have to create them by yourself because yeah, for diskless resources, you need them. And as you don't need any more information about them for the default ones, we already created for you. So what we'll do now is we will create a storage pool. And yeah, let's show you what options you have. So yeah, you have Exos. Then for playing around, if you don't really have a disk or a block device available, you can, for testing, use the file provider. It will not be very good performance-wise, but for playing around with LINSTOR, it's usually good enough. Then you have LVM and LVM Fin. Yeah, OpenFlex is also some other technology. Then you have remote SBDK and SBDK, which I won't explain for now because then my speaker slot will be over in a few minutes. And then we have ZFS or CFS, however you want to call it. And we will for now create a CFS pool. So what do we need? You need to name the node where you want to create it, the name for it. I will go here with our default name, which is default store pool. So if you never specify the storage pool by yourself, LINSTOR will fall back to this name. So if you have just one storage, you can just name it like that. And if you have some more than one storage pool, you could name one default storage pool and always know, yeah, it will fall back to this if it doesn't find any other stuff. And you need the driver pool name, which will be the name of the C pool. And for my case, or for my virtual machines, this is stretch ZFS. So success. So this looks good. We can check again the storage pool list, and yeah, here its state is okay. ZFS supports snapshots. We have a total capacity of nearly 2 GB. It's not huge, but it's just for my test clusters. And we will just now do the same for the other two nodes. So yeah. And that's it for the storage pool setup of LINSTOR. What Phil mentioned before is we have this concept of resource groups where you have from some central point, you can specify patterns of how much replicas you want and in which storage pool you want to use for one resource group. So you can separate stuff like HDD and SSD pools. So you can put them into storage classes like by speed, or you can also do fancy thing and configure racks mapped to storage pools, to resource groups. So you can list them right now. So again, we have one default resource group. So if you don't specify a resource group, for example, when creating a resource definition, it will be by default in the default resource group, of course. But for the demonstration purpose, I will just create one. And we'll call that CloudStack. It will have a replica count, or we call it here place count of 2. So whenever we spawn or create a resource in the resource group, it will have 2 replicas. And here, just to display your short options you have, so you can specify in which storage pools you want to use in this resource group, which diskless storage pools you want to use, because you can have more than one diskless storage pool with different option set, but it's a more advanced topic. And you have all kind of other filters and resource separations. So if you don't want to have some resource on the same node or on the same rack, so but it's all more advanced stuff. So for now, we could leave it like that. Then resource group also has volume groups, which are not that important. It's just important to know that the usual case, like for CloudStack or any other virtual machine orchestrator usually have one volume. And so you have to create one volume group for that. So yeah, so now we have a resource group CloudStack with place count 2 and one volume, which has the volume number. Is a volume group with the number 0. So and now what we can do is we can just create a resource there from this resource group. And this command is called spawn here. Then you have to write the resource group name and the name of your new resource. So let's call it test resource 1. And then the size you want to have. So let's say 300 megabyte. And now the magic happens. So now the LINSTOR controller will check how much space do I have on all my storage pools, and it will start to pick 2 nodes where it wants to place the diskful replicas. And because we have per default a feature called a tiebreaker, this is for DBD quorum. I'm not sure if Phil mentioned in the first session what quorum is and how DBD usage is, but yeah, this is the tiebreaker node, which is in the end just a diskless storage node in DBD speak. And we can see now we have the resource test resource on node 1, 2, 3. On one node, it's the tiebreaker. So on one node, we have just a diskless resource, which you can use like any ordinary resource. It's just that the reads and writes will go to the network. And on the other nodes, the writes will directly go to the disk and also on the network, of course, to replicate, but the reads will be local. That's one of the advantages. So yeah, we can also, because I have it open, here's the fancy UI we have, which you get if you're a customer of LINSTOR or Limbit. So here's basically the same information, just a bit more graphic. But back, so what else can you do with this? Yeah, I wanted to show you how this looks then in the end on the nodes. So this is node 2. And you will see we have now here a device, DBD 1000. And this is our block device, which is resource, the test resource 1. And why the 1000? 1000 is the minor number. And you can also see this in the volume list output. So here you get the device name. And this is the device name you can use to place a virtual machine on it, create a file system on it, and have your database there. Yeah. So we can create here now an ext4 file system. So it's done, and yeah, let's mount this. So this is here now, the last line. available of 250 megabytes because yeah, our resource was 300 and some reserved bytes from ext4. This is usable, and now we will just create a file there. So we have my test file there. And what else you see now is, as we have mounted this resource now, or this DPD device, it is now in use on LINSTOR 2. And as soon as we unmount it, it will be unused again. This is because of the DPD feature of auto-promoting. So if you don't explicitly promote, primary a resource, it will stay secondary, and as soon as you use it, it will become primary if it can. And to show you now, I will switch to the LINSTOR node 3, and I will mount here the same DB device. Oh no, let's switch over to the diskless resource. And I will also show you that this is really diskless there. So here's my ZFS list, and here we have the backing storage device for the resource, which is ScratchFS, ZFS, test resource 1, and the volume number. And on node 1, where it's diskless, we have nothing except for the storage pool itself, but we have the DPD device. And now we will mount that one. And we can find my test file from the other node. So this was more DPD magic than LINSTOR magic, but nevertheless, it's also always amazing to see it working. Yeah, so what else can you do with LINSTOR? You can additionally also, let's unmount it again. So you can do snapshots on resources. So right now we have no snapshot, but I can now create a snapshot on this resource which was created. Oops, typo. Yeah, of course. So yeah, this is the output from the client if you ever make some mistakes. So now I just forgot to specify a snapshot name. So what LINSTOR did now in the background, because this is now LINSTOR magic, it suspended I/O on the DPD device. So we want consistent snapshots. So we suspend the I/O, so no one can write, I will do the snapshot and have some inconsistent snapshot state there. So DPD will freeze all I/O to the backing device. Then we take a snapshot of the backing device and then we resume I/O. And if we check now again, we see LINSTOR snapshot list. We have now a snapshot of this resource. And we will now just demonstration purpose, I again mount DPD device and add another file there. Oops. just test file currently. And I'll create test file after snapshot. And now we have an additional file there. And now I will revert the snapshot to the previous state. Of course, it's called rollback test resource 1 and the snapshot name. Yeah, so we can't do this while the DBD device is currently in use, so we have to unmount it. And if we mount it, that's now again. Our test file after snapshot is gone. So yeah, back in this, yeah, there's a whole lot of more that LINSTOR can do, and if I would show you all, we need a few hours, I guess. It's just a list of all commands LINSTOR has, so it fills already a lot of pages here. So yeah, snapshots. We have now a new feature is now this called backups. So we have now backup shipping, so we can ship such snapshots which has created to S3 storage or to another LINSTOR cluster and reuse it from there, or get it back from S3 and then continue to use it from somewhere else. And yeah, this basically concludes my short demonstration for now, and I guess we will have a few questions to answer.
Yeah, it looks like we've got a few questions. So with regards to upgrading LINSTOR, can you explain the process of that and if it impacts your data availability at all?
Actually, this, as Phil mentioned before, it's pretty easy because your data availability is not touched in any way. So even if one satellite crashes or the controller would crash, the only thing you would not be able to is to create a new resource or make snapshots or change anything what LINSTOR controls. But DBD and all other data stuff, layers, block devices will stay or operate like they were. And so the usual process for upgrading is get the new packages, so apt install or apt update or yum, or now it's called DNF, update your LINSTOR packages and do a system restart of them, and that's it basically. So database upgrades and is all handled by LINSTOR itself, so there should no manual intervention needed.
Yeah, here's Phil. I can only back up that statement. I do LINSTOR upgrades on my development systems, and it is yum install. That's it.
Easy enough. So as far as DRBD's integration into LINSTOR, is LINSTOR capable of using every feature that DRBD has?
Then let me take this question. And so I would say nearly every feature. So all of the regular features it covers. So you can control any DBD tuning knob through LINSTOR. The only exception is we have this concept called stacking in DBD. That is something that is not represented in LINSTOR.
I believe that's going away, isn't it? Or at least that's on the roadmap to remove stacking.
yes, stacking is a very clumsy feature. So if we have a complete replacement for it, it will go away. So it doesn't make sense to bring that to LINSTOR.
Okay. The next question, how about monitoring resources? Is there any integration with Prometheus?
René, you want to take this one?
Yeah, yes, there is. So LINSTOR controller has a metrics export URL. So there are the most big resource export, but we'll also mention if you want to have advanced statistics about DBD usage, the newer DBD, it's called Promote. No, is it Promote? No.
Reactor.
Yeah, a new DBD Raptor has also this functionality for DBD itself, and there you can really get read and write statistics also out of that. But LINSTOR has pretty basic Prometheus exporter, and you could also write one just by the REST API if you want a more detailed one, or if you're missing something you might think is needed.
Okay. Next question is, do you support storage virtualization? Meaning, can you use old storage, consume its resources in LINSTOR, and then export it to new orchestrators like Kubernetes?
Let me take this one. The answer is yes. This is what we make all this for. So whatever your old storage is, if you attach it by fiber channel or if it's directly built into your servers, the old storage just needs to be a block device on Linux. And yes, the whole stack, DBD and LINSTOR is exactly that purpose. It is storage virtualization, gives you all the features, replication and deduplication and whatever. And then you connect it to Kubernetes or CloudStack.
Okay. The next question, how to interpret layer stack at resource groups. So apparently there's an option within LINSTOR when you're creating a resource group about the layer stack. Can you elaborate a little bit on that?
Yes. This is basically where you define how your layer stack looks like. You can have this on the resource group or on resource definition level. So for example, if you want to have DBD with Bcache or write cache, you would use this layer stack option and then say, yeah, DBD, Bcache, and on the bottom layer storage, because you need storage. You have to somewhere write your stuff. And yeah, you can see which options there are if you use the help in the LINSTOR client.
Okay. Are there any network recommendations for LINSTOR satellites, such as LACP? I'm not sure what that means.
I think LACP is the link aggregation something.
Okay.
So I would describe it as layer 2 network redundancy. And let me put it that way. LINSTOR and DBD are quite agnostic to what you do on your network. So it will work on your bonding interfaces, which is the Linux name for link aggregation for layer 2 redundancy. But DBD, for example, can do its own network redundancy. So then each connection simply has two IP addresses on each end, and it fails between the two paths when one path goes offline. And on the LINSTOR side, well, it doesn't, well, I don't know. René, can it have like multiple addresses for each satellite? Or just is there just one address for each satellite?
Now you can have more addresses, but you can only have one active one.
Oh, okay. So there's no automatic switching feature by now. Okay.
I don't think so.
Yeah. But when you think about other network redundancy concepts like using BGP routing, I think that would just work.
Okay. One of the other questions we had was with regards to LINSTOR and its ability to work in various cloud vendors. So obviously this webinar series is around Apache CloudStack, but will it work in AWS or Google's cloud or compute platform? I think the answer is a resounding yes, right? We've tested on both of those platforms.
Right, that's the answer. And Brian, do you have it at top of your head? I think we've blog articles published about it, right?
Yeah, we also have a tech guide on how to implement LINSTOR into AWS, written by one of our engineers, Matt. And then I don't think we have any articles on Google, but I know that we work very closely with Amazon in integrating LINSTOR into their cloud platform. Okay, potential advantages using LINSTOR versus other storage virtualization products. So what differentiates us between everybody else?
Let me start here and you can add as you like. So I would say number one, it is open source. So that has lots of advantages, and there is a vendor that is ready to provide you support around the clock. That's Linbit. When I compare us to a few competitors, one advantage is performance. We do extremely well there. So there's this blog post about the million IOPS records. And when you read it carefully, you see the other players we compared against. And the last thing is resource consumption. So as I said before, it uses little CPU and memory. And when when I look at our competitors in the field of Kubernetes, the other players use containers or multiple containers for each volume you have in the system. This is not the case with Linbit SDS. So with Linbit SDS, you only have a container for the controller and I think containers for the satellites, but the number of containers doesn't change if you create 1,000 persistent volumes. So here are the huge differences.
Yeah, I think one other advantage that comes to my mind is we're not proprietary by any means. So I mean, and we're, like you've said before, this is one of the things I think is really cool about LINSTOR is we're not reinventing the wheel. Like we're using LVM. People know how to use LVM. So if you're using LINSTOR and you have LVM volumes with or without DRBD, and you decide one day you don't want to use it anymore, you simply remove LINSTOR and then you use LVM commands or whatever your preferred tool is to access your data. So I think that being said, by using existing components, we're not introducing any instability. We're actually providing additional stability because these tools have been developed for many, many years.
Yeah.
I think that's a very strong argument for us.
Yes, absolutely.
Okay, it looks like that was the last question. So we're going to go ahead and wrap this up. Thank you very much for your attendance. And I think we're going to start our next webinar here in about 8 minutes. So hopefully we'll see some of you there. Thank you very much.
Thank you.